Today we'll be beginning chapter 10, which deals with conic sections, which are the hyperbola, the parabola, the circle, and the ellipse. Before we get into working with those shapes and their equations, we're going to do a little bit of review here in 10.1, starting with the Pythagorean theorem, which I'm sure you're all quite familiar with. And the Pythagorean theorem basically says that the sum of the squares of the two shorter sides in a right triangle will be equal to the square of the hypotenuse. And using that information, if you're supplied two of the three sides, you can always find the third. Very simple stuff. If I take 12 squared plus 9 squared, that will be equal to my hypotenuse squared. So this is 144 plus 81 is equal to the hypotenuse squared. 144 and 81 is 225. Is the hypotenuse squared, and if I take the square root of that, I'll find that the hypotenuse is equal to 15. Now they might give me one side, one of the shorter sides, and the hypotenuse, so here I would have 5 squared plus b squared, the other short side, will be equal to 13 squared. 25 plus b squared is equal to 169. So b squared will be equal to 144, so b is equal to 12. You'll notice that we've dropped the concept of introducing plus or minus when we take the square root of either side. That's because we're looking for distance, and distance is a positive measurement. Okay, so we're ignoring the negative result. I'm not going to go ahead and do this third example. It's very much like the second one here. And let's move on and look at the distance formula. So the distance formula says that my distance can be found by taking the square root of the square of the difference between my x-coordinates plus the square of the difference between my y-coordinates. Again, a pretty simple formula to use. Much like slope, I need to be consistent about which is point 1 and which is point 2. So if I do my x-coordinates, I'll have 10 minus negative 2 squared. And if I do my y-coordinates, I'll have negative 2 minus 10 squared. 10 minus negative 2 is 12 squared. Negative 2 minus 10 is negative 12 squared. 12 squared is 144. Negative 12 squared is 144. So this will be equal to the square root of 288. Which is approximately 17. Okay. Normally we'd simplify this radical completely. I'm not going to go through that again at this moment in time. There'll be plenty of examples of that as we go through. If I were graphing 17, knowing that this is just a little bit less than 17 would be sufficient for graphing. Now I mentioned the distance formula is the Pythagorean theorem. It's a derivative from the Pythagorean theorem. And here's an example of how that works. So if I have 2 points, I have P and M, here and here. If I want to find the distance between those points, you can see that I can create a right triangle with the distance between those points being the hypotenuse of the right triangle. So then I could say that this side squared plus that side squared will equal this distance squared. And that's what I've written out here. So we've basically taken, c squared is equal to a squared plus b squared. I've replaced the c, a, and b with the names of my line segments. And then if I take the square root of either side, you can see that the distance MP is equal to the square root of the distance np squared plus the distance nm squared. And you can see that because this is a horizontal line, this distance can be found by the difference between the x-coordinates, and because this is a vertical line, its distance is the vertical change, or the difference between the y-coordinates, much like we did when we were working with slope. And then if I substitute these values in here in place of np and nm, you see that I have gone from the Pythagorean theorem to the distance formula. So that's how that works. Continuing on using the distance formula, I'm going to go ahead and skip this example. It was very similar to the one I've already done. And instead, I'll do this example with the fractions. I know many of you have concerns and issues about fractions, so we'll do the problem that has the fractions in it. It'll take a little more time, but hopefully you'll understand how this all works out. So I want the difference between my x coordinates, so I'll have -7/2 minus 2/3 squared, plus the difference between my y coordinates, so -11/2 minus -11/4 squared. And what I'm going to need to do now is I'm going to need to create common denominators. So my denominators here will be sixths, so I'll multiply 7/2 by 3/3 and I'll get -21/6. I'll multiply 2/3 by 2/2 and I'll get -4/6. We're going to square that. And my denominator here will be fourths, so I only need to convert the first fraction. I multiply this by 2/2 and I'll get -22/4 minus -11. That's going to be like plus 11/4 squared. And as we continue this process, -21 minus 4 is -25/6. -22 plus 11 is -11/4 squared. And if I go ahead and square this, I'll get 625/36 plus 121/16. Now again, we need common denominators. 36 is 4 times 9. 16 is 4 times 4. So I'm going to use both of these factors. They occur in the same denominator. I need to use the 9. That's a new factor. But the 4, I don't need to use this one because it repeats. So my common denominator will be 4 times 4 times 9. So that's 36 times 4, which is 144. I'm going to multiply 625/36 by 4/4, and I'll get 2500 over 144. And I'm going to multiply 121/16 by 9/9, so I'll get 1089/16. Now if we actually go ahead and do the addition, we'll get 3589 over 144. I'm sorry, this was not 16, 144ths, because I had to convert the common denominator. All right, when we take the square root of this, we're going to get the square root of 3589 over the square root of 144, which is 12. And we're going to go ahead and use our calculator to simplify this and get our distance. Okay, I'm not going to do that part. You can only use your calculators. But that's how you would go about doing it with these fractions. So complicated because we do have to create common denominators a couple of different times as we go through here. But then at the end of the day, it's still the same basic thing. Okay. Midpoint is even easier than the distance formula. If I want to find the midpoint of a line section, the coordinates of the midpoint are the average of the x-coordinates and the average of the y-coordinates. So here I would do -3 plus 7/2 for my midpoint. And here I would do 4 plus -1/2. -3 and 7 is 4/2. And 4 plus -1 is 3/2. So this becomes 2 3/2 is my midpoint. It's the same if I work with the fractions. I'm going to still again create common denominators, but we've kind of done that. These are the same points we used in the last problem. 2/3 plus -7/2, that's going to be the same as -7/2, and we're going to divide by 2. And negative 11 fourths plus negative 11 halves, that's the same as minus 11 halves, over 2. Same common denominator, so here I'm going to have 4 sixths minus 21 sixths, that's negative 17 sixths divided by 2. And that's going to become negative 17 twelfths. Here I have negative 11 fourths minus 22 fourths is going to be negative 33 fourths divided by 2, which becomes negative 33 eighths. Okay, so this would be my midpoint. So again, if our points happen to be fractions, that doesn't mean that we have to throw up our hands and give up. You can do it if you just simply go through and do it step by step. The last thing we're going to work on here in 10.1 involves a review of a lot of concepts from Chapter 2. We know that slope is equal to y2 minus y1 over x2 minus x1. We know that the slopes of perpendicular lines are negative reciprocals of each other, and we know that y minus y1 is equal to m times x minus x1 if we want to write the equation of a line given the slope and a point. Okay, so if we're looking for the perpendicular bisector, that's a line that is perpendicular. If I have my line segment here, a perpendicular bisector would pass through the midpoint at a right angle. Okay, so now with all of the information that we have from this section plus what we learned in Chapter 2, we can go ahead and find these things. First off, with 2 points, I can find the slope of the line. With these 2 points, I can find the midpoint. And once I have the slope of the horizontal line, I can use this formula to find the slope of the perpendicular line. With the slope of the perpendicular line and the midpoint, I can use the point slope formula. So let's go through that a little bit at a time. First, we're going to find the slope of our first line. M1 will be equal to 9 minus negative 6 over negative 4 minus 0, which is going to be 15 over negative 4. So the slope of my perpendicular line will be the negative reciprocal of that, which is going to, and when you say negative reciprocal, that's really change the signs and flip it over. So that becomes 4/15. So I'm going to use this, and I need my midpoint. My midpoint will be the average of the x-coordinates, 0 plus negative 4, which is 0 minus 4 over 2, and negative 6 plus 9 over 2. So this becomes negative 2 3/2. So I can take my slope and my point and put them in point slope, and I can write the equation of the perpendicular bisector. So y minus 3/2 will be equal to my slope, 4/15, times x minus negative 2. If I simplify this side, I'll get 4/15 x minus a negative, that's going to be plus. 2 times 4/15 is 8/15. And if I want to add 3/2 to either side, I'm going to need common denominators. That's going to be 30ths. So this is going to be y is equal to 4/15 x plus 16 30ths plus my 3/2, which is 45 30ths. So my equation will be y is equal to 4/15 x plus 61 30ths. That becomes my equation. Okay, that's finding a perpendicular bisector. Most of this, all of this use, was a review from Chapter 2. The only thing new we did from this chapter was the addition of the information about finding the midpoint. Okay, and that's it for 10.1.